In this video, you're going to learn about QLatin1String and QStringView. I will cover what are they and the use cases when you will most likely use them. Let's start with QLatin1String. In the last episode, we discussed the QString class. And as you remember, it stores 16-bit Unicode characters. It means that every character inside QString takes us 2 bytes. Sometimes it is not bad, because our application may need it for language purposes. But in case we know that our string is also SC valid, we can save up memory using QLatin1String. ASCII characters take only 1 byte, but we're allowed to use fewer symbols, of course. Let me show you an example from the documentation. Here we have this function. I already have it in my editor, and I execute it. So as you see, we create a variable of type QString with some type, then compare it, is it equals, and if yes, then we just qdebug true. I also have to include qdebug header. And then we do the same, but with the QLatin1String. Let's execute it, see what we have. As you see, the results are the same. But it is all about performance. In the first condition, we compare our string with the C-style literals, const char. These literals implicitly converted to QString before comparison. Meanwhile, in the second condition, we make a temporary QLatin1String. This class is a lightweight read-only string wrapper for USST Latin1 encoded string literal. Here it compares the QLatin1String object directly to the QString without converting it. Comparison is faster because it avoids memory allocation and leverages optimized Latin1 to UTF-16 comparison routines. It means that just makes it faster. Let's take a look at another example. Suppose you want to log some data and make it efficient. I'm making username, action, and ID just as variables. Let me paste it in my editor. Here, we make it just as variables, but it could be read from any other sources, of course. So, then I want to concatenate it and just log it to the console. In the first case, each literal is implicitly converted to a temporary QString. This one, and so on. Then I call to convert it to a number. To convert number to a string. When we use QLatin1String to wrap SC compatible literals, no memory is allocated, and we don't perform any UTF-16 conversion. But here, the concatenation involves memory allocation and UTF-16 conversion for each literal, each of them. And here we don't do that, so it just makes it faster. And if you want to log large amounts of data and make it efficient, it is better to use this kind of logging system. So, as I said, in the first case, in this slower case, QString implicitly converts and allocates memory. And in the second case, no memory is allocated and it just works faster. To wrap up your knowledge, I made this table with the key differences between QString and QLatin1String. Here you have everything I have talked about. So encoding support, QString supports UTF-16, meanwhile QLatin1String SC. Then memory usage 2 bytes per character, 1 byte per character. And performance is slower for ASCII strings and faster for ASCII strings because it uses it mainly, and here the QString is used for any other, I mean, all kinds of characters in all languages. It just have more symbols that it can store. and QString is making implicit conversion of literals. The next class we got here is QStringView. QStringView is a kind of manager for many strings. It references a contiguous portion of a UTF-16 string, but does not own it. So just as you see on this diagram, it can point on some portion of the string, but it not own it. So you can search here, you can extract some data, and that's all what you can do. But after you pass some string to QStringView, care must be taken to ensure your string lives longer than QStringView, and no references to deleted data are stored. Because as everything here, you should ensure the original string outlives the QStringView and prevent dangling references. This means that if, for example, QString goes out of scope and deleted, then QStringView should be also deleted, and it can't point on dangling pointers. And that is the thing that programmer should care about. The main use case for this class is as a function parameter type. Look at this example. Let's say we have a string in format key equals to some value, like this, and we want to make a function that helps us get this value. Earlier, we would do something like this you see right now. So let me copy and paste it to my editor. And let's also call it. And QDebug, extract key, and I don't know, key equals to 1, 2, 3, 4, 5. Fine, let's see if it works. It works, we get 1, 2, 3, 4, 5. And because we don't want to make a string modifiable, I made it constant. And to prevent the string from being copied, we take only a reference to it. But see, here's a couple of problems. A function can accept only a few types of strings, only like this literal, and maybe if I QString str equals to, let's make the same, maybe now ABC, I can also pass it. But in case if I have something like, let's make the array of construct t, strc to new equals to, and let's put like key e equals 1, for example. If I want to pass something like this, I can do it. Of course, it's pointer. Yes. Pointer to this array of characters. And in case I want to call it with this, I can do it, because no mention function for call. I get error. And of course, finally, after testing everything, we have to delete it. Don't forget, if we make raw strings like I had done here. And also, it's the first problem that I showed you. And the second problem is that function returns a new QString, which involves allocation and copying of the substring. So here, let's break down what is happening inside our function. We get in this starting string, so in our case it's key equals to. QString literal is just a macro to make string on compile time. Then we check if our string that is provided is starting with the key equals to. And if yes, then we return with the help of method meet that gets a string from the starting point that we provide. In our case, it's the size of the start is 4 because we start from the this index, and then we continue to the end of the string, and we return it. And in this case, if we return a QString, then it involves allocation and copying of the substring, this substring we extracted. I want to show you how to deal with it and see that example. And this is another function that does the same thing, but with the QStringView. Let me copy and paste it. Here we have. I change name. It does pretty much the same thing, but only here it gets literal. It gets Unicode literal, then checks it starts with and return. And so the type that it has as parameter is QStringView, and return type is also QStringView. If I call it, for example, let's test the same things. From the start, it's maybe 2, then 2, 2. And here we have to pass this Unicode literal. Then str2 also. And as you see, we can call whatever parameters pretty much we want, because now I will show you why. Let's call and see what we got. We have a problem. Oh, of course, yeah, because here I should, when I make this kind of string, we should pass the ending of it, so our code knows where the end is. And here we have it, everything is correctly. So the parameter is not marked as const, but we can't modify it. As here, for example, I write str append. I even can't write something like this. And the same applies to the QStringView. I can't write something like append or str, whatever method that modifies. There is just no. So we can modify it because QStringView doesn't own a string. Also, we not mark it as a reference. So it can accept all compatible types of strings pretty much, as I showed you here. And it's the list of these compatible strings is bigger. And the function also returns a QStringView, which is a lightweight view of the input string. So no new allocation or copying is performed. But of course, the color, in our case here, the color who calls method, who calls function like this, needs to manage the lifetime of the original string. And the QStringView is invalid if the original string is destroyed or goes out of scope, as I showed you, as I said you previously. So also, we not mark it as a reference, but it is not copied, because QStringView is just a reference by itself to the string. As I see here, I repeat it. Accept all QStringView compatible strings, no memory allocation or copying. It just returns a lightweight view, and function can't modify the string and doesn't need to create a new string. And I think this is it for today. I hope you enjoyed today's episode and the presentation that I made. I think firstly, the history of my channel helped you understand the topic better. In the next episode, we will start exploring QML and finally make some GUI. So don't miss out.